All right, so what I'm going to do is we're going to go through this practice problem that you guys were asked to do for homework. And I'm going to actually write it out, and you guys are going to write it out too, just to be able to double check yourself and make sure you have the correct work. Then I'm going to give you one more practice problem. And then what you're going to do, you can work with your partner, that's fine, is you're going to do this one example problem on your own. Okay? And then you will also have a reading and some questions to do. So you're going to write all of this out, and then you will scan it and put it onto Schoology. Okay, so let's look at the first example. And this is, you've already done it, but you're going to double check your work now because you didn't have me doing it with you. So it says, I want to determine the total number of calories in a Snickers bar. When I break off a 1 gram sample of the bar and burn it under the calorimeter, a calorimeter that contains 1,000 grams of water, the temperature of the water increases from 25 degrees Celsius to 28.5. The first thing I need to do is figure out the heat in calories that's released when I burn this 1 gram sample. So what I need to do is I need to use my formula, Q equals MC delta T. Okay. I'm solving for my heat. I know the mass of the water is 1,000 grams, and so I'm going to plug that in for my mass. I know my specific heat, which for water is 1, so this is grams. This is 1 calorie per gram degrees Celsius. Okay. And then to find my change in temperature, I'm going to do this right up here. My change in temperature, remember, is going to be my final temperature minus my initial temperature. Okay, so my final temperature here is 28.5. My initial is 25.0, and so when I subtract, my change in temperature is just going to be 3.5 degrees Celsius. Okay, and so what you should notice with your units, if you were to actually cancel out units properly, what you should notice is that your grams cancel, your degrees Celsius cancel, and what you're left with is calories. And so I got 3,500 calories, which seems like a lot, but we need to really quickly remind ourselves what we're meaning when we say that many calories. So the lowercase calorie, what that means, that 1,000 of these little calories equals 1 big calorie or a kilocalorie. This calorie is what we use when we're talking about a nutrition label. And so it says calculate the heat in calories. So what I need to do now is take the 3,500 little calories, and I need to convert that into big calories. So 1 big calorie on top, and I'm going to put little calories on bottom. So notice the little calories cancel. I'm now in big calories. So there are 1,000 little calories in a big calorie. So then all I'm doing is taking 3,500, dividing it by 1,000, so I get 3.5 capital CAL. Okay? Not too bad. All right, now it says calculate the heat in calories per gram burned. So I know the total calories, capital CAL, is 3.5 calories. So I'm going to put 3.5 capital CAL. And that's that many calories are released or are burned or absorbed for every, well, how many grams of my sample did I burn? Well, in this problem, it tells me I burned 1 gram of sample. So I'm just going to divide it by 1 gram. And so my answer here would just be 3.5 calories per gram. Okay, and that's my answer. Now, why do I have to do this? Well, look at the next problem. Looking at the nutrition label, calculate the total number of calories in the Snickers bar based on your experimental findings. Well, if I look at the nutrition label, it tells me that 1 serving, which is a bar, has a mass of 57 grams. So yes, I took a small piece of it, 1 gram, and burned it. I didn't burn the entire thing. So I need to take into account the fact that it's not 1 gram that I'm burning and measuring the heat of, but 57 grams. So I'm going to start off, and I'm going to put my given, which for this would be 57 grams, because that's the mass that's actually burned, 57 grams of my Snickers bar. Okay? And then I'm going to get that into calories. Okay? Well, in the previous problem, I just told you that 3.5 calories are released per gram. So the good news is I can just put grams on bottom, grams will cancel, and calories up top. So now if I put 3.5 calories for every 1 gram, When I multiply, that gives me 199.5 calories. So based on my calorimetry, that entire Snickers bar should only have 199.5 calories in it. But if you look at the bar, it has 271 grams. So the actual value would be 271 grams. So we'll talk about why in a second. Well, sorry, 271 calories, right? So to determine my percent error, remember, it's going to be the absolute value, just meaning it's not going to be a negative value, of my actual, how many calories it actually has, minus what I measured in the lab, close my absolute value bracket, divide that by my actual, and then multiply this by 100%. And so what you end up getting, keep in mind your actual is going to be what it really is, 271 according to the nutrition label, minus what I got in the lab, which was 199.5, absolute value of that, even though you don't really need it, divided by the actual, which is 271, multiply by 100. And if I'm staying consistent with, so I got 26.4%, and the reason why I rounded to 26.4% was so that I would keep 3 significant figures. Okay? All right, why was your measured value less than your actual value? So remember in the video, he talked about the fact that you're burning a Snickers bar, right? And the heat is going to be absorbed, especially when we do it, we're going to have a calorimeter on top. So the heat, well, some of the heat will be absorbed, but keep in mind, you also are going to have heat lost that isn't actually collected by the water. And so that's why whenever you do a calorimetry lab in a high school science lab, the value you get in all likelihood is going to be less than what it actually should be. So let's look at the next example. So here I have a 0.5 gram sample of my candy bar, and it's burned in a calorimeter that is surrounded by 500 grams of water. It says the temperature of the water in contact with the candy was measured and found to increase from 21.2 to 25.2. So if you want to challenge yourself, pause this video and you try it yourself. And then I will actually do it with you. So calculate the amount of heat and calories released when 2 gram sample is burned. So I need to calculate the heat. So Q equals mc delta T. Remember, my mass here is going to be the mass of water because I'm measuring the temperature of the water times my specific heat, which is 1 calorie per gram degrees Celsius. And then I'm going to multiply that by the change in temperature. So change in temperature equals my final minus my initial. Okay, so my final temperature here is 25.2 degrees Celsius. My initial is 21.2. So my change in temperature is 4 degrees Celsius. Okay, so 500 times 1 times 4 is 2,000 calories. Okay, so that's that. Now it wants to know the calories in capital calories. So again, remember, there are 1,000 little calories in a big calorie. So 1,000 little calories in a big calorie. Okay, so get rid of little calories. And so I have 2 big calories there. Okay. Then it says calculate the heat in calories per gram. Well, I have 2 capital calories burned, and I burned 0.5 grams of my candy bar. So instead of dividing by 1 like I did in the previous problem, I'm going to divide by my 0.5 grams. So what I get is 4.0 calories per gram. Okay. So now I'm going to look in the nutrition label, and I know the total mass of my candy is 42 grams. So if I have 42 grams of candy, I want to get into calories, and I know that there are going to be 4 calories for every 1 gram, which means that it's going to release 168 calories of energy. Okay? So let's compare that with the actual value. The actual value given to you, look at your nutrition label, is 210, which means that my percent error, which remember is your actual minus your measured divided by your actual times 100%, is going to be 210 minus 168 all over 210. Then you're going to multiply that by 100%. And so the value that I got for my answer was 20%. Okay? And that's your answer. So what you're going to be doing now is completing number 1. You can work with your partner, that's fine. You're going to complete number 1, and then you're going to do this reading and answer the questions along with it. All right?